All right, it's top of the hour. I'm going to wait a few seconds here just for everybody to join. For those that already joined, thank you so much for spending the time with us here today. You could have done so many other things, but you choose to spend it with us. And we're always grateful for the attendees that we've got with our webinars here. Before we get cracking, I do have a guest today with me on the webinar. He is not a new face. He is someone that's been joining me for a few webinars in the past already. So I just want to welcome Mr. Vaughan Rampersad. Vaughan is the product manager here at Flow Software. And then obviously for the guys that know me, my name is Lenny, part of the customer success team as well. We've got Graham as well. He's part of the panelists today. He's a silent observer. So Graham, welcome as well for joining the webinar. So these webinars that we have is all around the buzzwords that we have in the industry. And the last webinar we had was a little bit more product focused. So we discussed around what the new version of Flow entails and all the new features. But this time we are back around providing some clarity about some of the buzzwords that we see in the industry. The first one that we had was around the word analytics. We explained a little bit of what we see analytics is and where does Flow fit into the analytics continuum, as we call it. I know it's a big word for a Wednesday. I'll try to explain a little bit better as we go through it. But today is all around context. All right, so what does it mean for us, at least, when we say we need to provide context to data to turn that into information? And that's what we're gonna focus on today. But let's just recap a little bit on the analytics continuum. As I said, big word. The best way for me to describe continuum or a continuum is my high school or my school progress through school. You know, you've got your different grades and you start kind of at the bottom. In the olden days, some of us were lucky and we skipped a few grades. But the point is, it's small incrementals as you go through the grades. You learn new things, but technically you can't skip a grade, right? You have to go through the grades to at the end get to your national diploma or your matric certificate or whatever it is that you achieved. And it's the same with analytics. So kind of start at the bottom, work yourself up. And there is 4 pillars that you can work through the analytics continuum. The first one that we have is descriptive analytics. That is where we just look at historical data. We say what happened in the past, what was my total throughput for the day and for the shift as an example. But the thing with this is that it's automated, it's repeatable. So when you see that daily or shifting number at the end of the shift every day, you get the same repeatable result from that. So it's institutionalizing your kind of descriptive analytics. The next level in the pyramid is what we call diagnostic analytics. So this is now where we talk about why things happen. All right. So yes, I might have had throughput for the shift, but why is it lower than the day before? And the only way that I can answer those questions is if I add context to the data, and we'll see what that means going through the webinar here today. Then we get to the predictive side. That's obviously now trying to make projections into the future or forecasting in the future based on historical data, so that we can see potentially, hey, if I continue with this current rate of production, will I actually be making my end of the shift total or not? And then the kind of the holy grail is what we call prescriptive analytics. That's where we now take the best outcome from machine learning to say, hey, things are going to break in a few months, but then coupling that to tribal knowledge that people give us to actually now say, okay, I know it's going to break. Here's are potential things that I can actually do now to fix it, replace this bearing, do a service, or whatever the case. So it's mixing and matching all of that tribal knowledge with the actual data that we have. Now, today we're going to talk about contextualized data. All right, and I've kind of tried to have a little bit of an example to explain what this means. What does contextualized data mean? So I got a number from the internet, like where we get all our stats and numbers from, right, from the internet. But we all know this, right? There's always a Twitter or a social media feed that says, oh, this website's been hacked and X amount of usernames and passwords were leaked all over the internet. Now, Vaughan, if I ask you or tell you, hey, Vaughan, 1.3 million passwords were leaked, are you concerned?
I don't know whether I should be concerned, Lenny. Is it Apple IDs or is it my dadjokes.com password? Is it one of my passwords? I have no idea.
Exactly. So this is exactly the point that I'm trying to make. Without context, I can't answer those type of questions, right? So should you be concerned? I don't know. Let's look at the first piece of context that we normally associate to data, and that's concept of time, all right? So when did this happen? The last shift, the last day, whatever the case is? Well, I can tell you that this is quite a long time ago. This happened in 2010.
I wish I could say I was too young to have a password then, but I still might be impacted.
Okay, still might be impacted, all right? If I tell you from where they had the breach, maybe that will help. Okay, so this was from a company called Gawker Media.
Yeah. No, I don't think I've ever. Oh wait, hold on. What companies does Gawker Media own?
Okay, so they have a few sites, right? So they've got two blog sites, Lifehacker and Gizmodo. So I think some of us are old enough to might have a Gizmodo account. I think I had at one point. So you can see adding the context is now narrowing it down if I should be concerned or not. Now, there might be two outcomes of this, right? So the first outcome would be, oh, yes, I actually do have an account. So I do have an account on these sites. All right. But you can argue that my password is, I use a very strong password. Passwords are always encrypted in these type of solutions, which is correct. So are you concerned? Well, I don't know. Let's look a little bit more in detail to the information here. So from all those passwords, only 14% of those passwords were cracked. Okay, so 14% of 1.3 million is only, and you can argue that's a very small amount. No one will be able to guess my password. So technically, you can argue that it's okay. I don't worry. The other option is you can say, no, I don't even ever had a password. So why should I worry about my password? The point here is how unique is your password? Doesn't matter for which site you actually use it. Because of that 1.3, of that 1.3 million, and from the passwords that they actually cracked, only 50% were unique. Okay. Now, this paints a very different picture. All right, so instead of 1.3 million passwords that we should be worried about, technically, we should be only concerned of 91,000 of those. This is now the 50% of the 14% cracked passwords that were unique or non-unique. All right, so why am I hammering on this, even if you didn't even have an account on that? If we add more context to this, of this 91,000 passwords, it actually had some terrible results. All right. Technically, I can guess some of your accounts. And the reason for that is the following. As we know, 1, 2, 3, 4, 5, 6 is always the number one contender for passwords. The word password was the second in line. But the two that I want to highlight here is actually the word lifehack and the word Gizmodo. And guess what? They were the names of the blogs. So technically, if I've got your email address, I can try and utilize this to get into any one of your accounts. Okay, and this is the power of context. Okay, so, and you can't make these decisions, and I hope everybody's logging in and changing passwords right now. But this is the point, that I cannot make these decisions without having the correct context to data. Okay, so why do we do the same in industrial automation? All right, so how do we at Flow address this kind of problem? Now, we've got a 5-step process that we create this analytical hub that we go through to provide this contextualized information to people, that you can actually make these informed decisions on if you need to go and change your password or not. Now, these 5 steps include to model the KPIs or the structure. Obviously, we need to be able to connect to a whole bunch of different data sources to pull the data from, to get all of the different pieces of information to apply context could come from various data sources. It might come from your plant historian, it might come from your MES database, it might come from your batch database. So all of these different industrial data sources that we have can potentially have quite a lot of data that I can use to provide context to a piece of information to actually ask these different what-if questions to do diagnostic analytics on top. Obviously, we need to clean it a bit. We need to transform it. We need to aggregate it. We need to detect events or event frames with it. So there's quite a lot of work that needs to happen inside of that transform bubble to get that right. Then we need to visualize it. I had a very nice and simple, bar graph that's been ordered from top to bottom. So I can actually see what was the top contender there. And that's then obviously the one that you would focus on. So visualizing your context is very important. I think in the future, we'll probably have a webinar about what is the best visualization techniques for different types of context that we have to data, but it's very important to have the right visualization component as well. And we might need to share it, right? We need to share that information that's now contextualized to your machine learning platforms or your Power BI or your business intelligence solutions. So always have the capability to bridge it out. All right, so let's go a little bit more technical detail around the transformation part. So how do I associate these different pieces of context to different pieces of data in my system? So let's imagine I've got a data source, which is a historian, and I've got a tag that changes. So each one of those dots represents a change in the value of that tag. And that can be my main source of data. This could be total production for the line. I might have data coming from another data source, Microsoft SQL database that can provide additional context to it. Who was on shift? What was the work order running? What was the actual product running? And I can go and create what we call tags within Flow. And I can go and create calculations based on these tags as part of the transformation process. Now, what we do with this is we create what we call point normalization on the data. And what that essentially does for us is it gives us this capability to do row-based calculations from the data that comes from these two data sources without any data loss potentially on that data sources. And in Flow, we can go and create what we call a calculated tag based on that. Right, some examples for calculated tags. I can filter out quality. I can filter out a band of information. I can filter out, based on the state. Was I actually supposed to be producing yay or nay based on my schedule? I can filter out certain conditions based on that. And very important is that I can do this from 2 different data sources. All right, now, what can we do with these tags? One of the things that we can do with these tags is what we call event detection, right? So I can take this tag and I can go detect an event. All right, why is this important? Events is probably one of the biggest pieces of context that we would be able to associate with our data. Examples of events, these include downtime event. It could be a batching, start of a batch event. It could be a product run based on the machine state. So I can then utilize that event to associate some pretty cool context with it. So let's do that very quickly. I'm going to go into Flow now. So this is the Flow configuration tool. And I actually have a machine state tag coming from my tag historian. So if I expand my namespace here, I do have a product state tag, a machine state tag, and this just tells me the state that the machine goes through, right? So there I got a typical kind of machine state. If it's in state 0, it means it's not running. Going into state 10, it means it's now setting up, busy to get set up. Then it goes into production state, which is state 20. Then I've got all these little downtime events that happens while we're busy manufacturing the product. And then the last state here is just cleaning in progress or my CIP state. So what I want to do is I want to detect this event frame of when am I actually running product. Okay, so I'm going to go and create a calculation to determine, am I running? So am I going into state 10 all the way until I get to the end of the production? And the way that I can do that is with a tag. All right, now I'm going to go and create a metric here. This metric here is going to be my machine state as an example. And what I'm going to do is I'm going to drag the tag from our historian into this metric. Okay, it's going to create a tag for me. And I'm just going to call it, this is my source tag coming from the raw source of that state engine. Now, what I can do with this guy is I can actually go and drop it on the calculator here. So I can take that source tag, drop it in the calculator, and I can now create what we call a product run, okay, based on the source data. So I can go just as I associated nicely in my model. Let's open this guy up. And in the retrieval here, I can now go and write a calculation. All right, so we know that when I go into state 30, that's the end of my run. Anything above 10 means I'm actually running from the machine state. So I can actually filter out all the rest of that data, all the downtime events, not interested in that, because I'm only interested in the actual product run itself. So what I'm going to do here is I'm going to say, well, if you're in state 30, and I'm doing an inline if statement here. Oops, my dyslexia again is catching up with me. If I'm in state 30, that means I need to end this thing. Else, if the value of that state engine is greater or equal to 10, then I know I'm in a running condition. Else, just return 0 as well. So I'm just filtering out all the other noise, only concern of that start and that end trigger. I'm gonna accept my calculation, just check that I didn't make any mistakes. And let's refresh here. Okay, so currently I'm 1. That means I'm running. Let's pop it out. Give it a little bit bigger time frame. And there we go. 1 and a 0. If I drag the state at the bottom here, I can see it starting when it's in state 10. And it's stopping when I'm in that state 30. So this is one of the processes of cleaning and transforming data, right? I literally took the state engine and I just transformed it into a Boolean true or false kind of scenario. Okay, I can use this now to create the actual event frame or the event detection. How do we do that? Very simple. I can now go and create an event, a lightning bolt here in my flow solution, and I can go and create a product run event. Okay, and I can utilize my tag to now trigger this event. So I'm going to use my product run tag here. When it is equal to 1, I'm just going to start it. And obviously, I'm going to end the event when it is 0. Cool. So literally, and I'm going to deploy it out. The flow engine in the back end will now go and query the data, the raw data from that data source. It's going to apply my calculation to it. It's going to detect the event frames. And this is the result that now sits within my flow database. Cool. All right, so very simple, creating the event frame based on the tag. All right, what is the next thing I can do? Well, the next thing that I can do is I can then obviously take this calculator tag and I can use this to create what we call period normalization. All right, remember that first piece of context that we associated to the 1.3 million passwords that were leaked was the year 2010, right? So that's a very important piece of context that we associate with it. So what Flow will do is we'll take the calculator tag and we will go and transform this in what we call periods. We'll do a period normalization. Now I can perform aggregations on top of the raw data that's now cleaned, and I can now go and store that inside the Flow system. All right, examples for this is production numbers, usages, equipment, revenue, cost, and then very importantly, those projections and forecasts that we can do. All right, now I've already done that. So I have created a measure back in Flow here. I have created a measure here that literally, again, looks at my source, which is a totalizer within my historian. I created an hourly measure. All right, so I'm associating the context of hours to this, and I'm retrieving it as a counter retrieval from that source. And I've created a daily number for this. All right, so very simple. There we go. I've got my daily values coming through here. So I know at least how much am I producing per day. Okay. Well, what if I now want to add the context of the actual event frame to that as well? Okay. Now, we spoke about it. What type of context can I add? I don't know. I can add what's the current shift? How much was produced in the shift? How much was produced per product that I manufacture? Right. And all of this kind of metadata that we have, I associate or add that to the event frames. Okay. We call them attributes. I can go and add an attribute on top of this. And I can say, okay, the first thing that I would like to do is maybe retrieve a point from the historian and associate the product code with that. So I can retrieve potentially the actual product that I'm manufacturing. And I can, you'll see in my historian, I actually do have an SKU that's associated with it. And I can literally just add that to my product to return that. I can go and create attributes based on calculations. So I can potentially go and create, well, what was the shift that was currently operated in this event frame? So I can do a calculation based on the shift. Now you can get the data from the event. You can look at the duration of the event. You can do automatic micro and macro stop association with this as well. But what I'm going to do is very simple. I'm just going to say, I would like to know what was the shift when I started this production. Okay, so I'm associating the product. I'm also associating the shift now to this data. I can also enumerate the product. So if it was a code, an integer value in my historian, I can enumerate it to actually be the string representation of that as well. Okay, very important. I need to make sure I didn't make any mistakes that I did. So that's very important to do, to make sure that you don't do any spelling mistakes. I'm just going to add my semicolon there, validate, and that is now a valid calculation. Cool, going to deploy it. And I'm just going to tell Flow, please go and associate these new types of metadata with the event frames that I've already detected. So I'm just backfilling it to apply it to the historical data. If I give it a bit of time to run here, there we go. I've got now the metadata around the shift. I also have the actual products that's running. Okay. How do I associate this now with the time frame, which I've got, which was the daily? Well, I can simply open up my source here and notice we called it context. And by default, we will have the context of the calendar already in it. But I can literally now just add the context. If I stop it, I can now add the context of the event. And I can also say, I also would like to see it per product, and I want to see it per shift. Okay, cool. Deploy it out. Flow will go and do its thing. Based on that, get the data and now associate the data within that. Okay, I'll come back to this when Flow is done with that. Now, the important thing here is that I can take this data and associate the event overlay like I've just done by associating the context to that measure. And I can now serve this data out. So I can serve out not just the event frames that we store, I can serve out the measures, and I can serve out these calculation tags and calculated tags. All right, so what does this mean? I can go and build out a nice dashboard potentially in another solution like Power BI as an example. Right, so I'm going to ask you the same question, Vaughan. I had a total throughput of 1.3 million units yesterday. Is that good or is that bad?
Lenny, you're not giving me enough information. Is it good? Is it bad? What product is it? How many units can I produce yesterday? I don't know. I guess from up in this thing, I need context.
Exactly. All right, so let's look at this. I created a little Power BI dashboard here. So this is utilizing our REST API to get this contextualized data from Flow into Power BI. And this is exactly what you see here, right? I can see for my different lines, I've got 2 lines. What was the total produced for line 1? What was the total produced for line 2? I can see them together, so I know line 1 made more than line 2. I've got a historical bar chart at the bottom here where I can see, if I change the date range, how much did I produce in a specific day? But I've got no clue if this is actually good or bad. At least there's some history. I know it's kind of consistent, but I don't know must I be concerned at this point in time?
It looks a little bit pretty, Lenny, but I don't have information yet.
100%. So by adding the event frames to the measures and having that metadata around shift and product, it could look completely different, right? Okay, so what we now have here is the same information, still throughput, but I'm now showing that throughput per product, and I'm showing that throughput through for the shift that's been manufactured. Now, a scatter plot is probably one of the best ways to analyze these what-if scenarios. So for diagnostic and analytics, scatter plots are great. Power BI has got this cool feature where I can actually play this scatter plot, and it will show me as the days progress what is the bad production actually going to do. Now, we always kind of blame the night shift guys, right? That's kind of the first thing that we do. So let's play this and let's see what's happening here. All right, so not looking too bad. The bad production that's on the x-axis here is going, oh, there's something happened extremely bad. So if I move this back, on the day of the 12th, if I can look at the path that this thing is doing, I had a massive spike here in the production for the 12th. So my morning shift produced 20,000 band units. Okay, so now at least I know on the 12th for the morning shift, there was an issue. Okay, what product was I running? Well, let's refresh this. Let's move this guy to the 12th as well. Oh, it was product 1. So on the 12th, for product 1, morning shift, there was an issue. Okay, now at least I know what is the context around it, and I can now go and do a proper intervention. What happened on that shift? Why is it always product 1? And maybe there's a pattern. Maybe it's always morning shift with product 1 that's causing the issues, and I can actually go and associate and look at that and to try and fix it. The point is that I need that context to make these type of decisions. All right, I know very quick, I've utilized the Flow API for this. The Flow server does serve this API. I utilized the Measure API here to get all the data. And there's a very important little tick box here that says, please associate my attributes to the data as well. If I execute this, then it will give me all the data. It will tell me it's a daily aggregated measure for my total bad production. But more important, I associate the product to it, as well as then the shift information to it as well. So very important to get that context associated with. And this is what I've utilized to build out the Power BI reports. All right, so I hope that gave you guys some idea of the type of context that we can have in Flow, utilizing events and attributes on top of that. And it's really very important to do that, to go from your typical diagnostic, descriptive analytics to a little bit more, the next phase in the continuum, which is your diagnostic analytics. Okay. Right, I want to end off with 2 things. I want to congratulate ACC, Automation Concepts and Controls. They did their certification. One of the engineers certified with Flow. He did his certification project, and they are now a premier certified integrated Flow. So very congratulations to ACC on that. And then just a little bit more on the resources here. We've got 2 more new success stories. One based on Coca-Cola, and in Africa's Coca-Cola Beverages Africa, they rolled out Flow for downtime detection on their filling lines. And then, as we all know, water is quite a scarce commodity in Africa. So quite a cool solution there to monitor boreholes to supply drinking water to a small little town in the Karoo here in South Africa. So please go and read out those 2 new success stories. Links to these, as well as the recording of this webinar, will be made available as well. Guys, that is the end to the half an hour that we've got scheduled with you guys here today. I hope that was informative. I hope when you see the word context, you put it in a different light. Excuse the pun. And I hope you go and change all your passwords after this as well. So yeah, please make sure that you go through the steps in the continuum and be assured that Flow can be this analytics hub that you can build this solution up. I thank you for that, for spending the half an hour with us, and I hope to see you next time. We will probably talk a little bit more around visualization and the different type of context that we've got on data. Cool. With that, I say goodbye and thank you very much.